So today we're going to do the applications of sine and cosine. That means you take what you learned and you apply it to something, which in other words, a story problem. Story problems can be easier in a way though, because it gives you something to wrap your mind around instead of just like a bald word problem. All right. So let's review once again how we get these things from our equation with our A, B, C, and D in here. Amplitude is which part of this? A, except you have to do what to it? Good. Absolute value of A. It's a distance. It can't be negative. Which is gonna make even more sense now. Sorry, I didn't mean to put an equals there. Absolute value of A. Because lots of times in word problems, you don't get negative answers because you're talking about like time or distance, and those things can't be negative. All right, period. How do you get that from your equation? So you use B, it's 2 pi over B. And again, we absolute value that. It can't be negative, it's a distance or an amount of time or something like that. All right, what is your vertical translation? Which letter gives you that? D is your vertical translation. And then for the range, you want to think of it this way. Your center line of your wave, that's D, however much you shifted up or down. If you didn't shift up or down at all, it would be at 0, right? You know what I'm saying here? But wherever you moved it, that's your D value. And here's what your wave is going to look like. This distance away from the center line is which one of those letters? This distance. A, that's your amplitude. So you have that center line, and then you go that much above and below it. So how do you get your range? How would you figure out what this low value is? D minus A, good, comma, and then your high point, your maximum is D plus A. So you figure out where the center is and then how much above and below it you went. That's going to be really applicable when we read these word problems. All right, so here we go. A signal buoy in the Chesapeake Bay bobs up and down with the height of its transmitter in feet. So we've got feet above sea level, modeled by this function. Time is in seconds. You guys understand what a buoy is and how a wave works? Like, use your imagination. You've all been to the ocean, right? Like, waves. Okay, making sure. The height is going to vary between 1 foot and 9 feet. So 1 foot is that low, that minimum. 9 feet is the maximum. What is the period of the function and what does it mean? So it would be 2 pi over what? Look at your equation. And it's not a very nice number, like doesn't turn out very pleasant, but it's 2 pi over 4 pi over 7. You did do some like this in the delta math last time. They threw some at you like this. That would be 2 pi times what? 7 over 4 pi, the reciprocal. When you divide by a fraction, you multiply by the reciprocal. You're just going to flip it over, all right? Which is good because what happens to the pi's? They cancel. And then we're just going to multiply these. If you want to put the 2 over 1, if that helps you, you can do that. Just multiply the numerators and multiply the denominators. What do you get? 14 over 4, which would be 7 over 2. All right, so there, we found it. We got a numeric answer. The second part of that is, what does it mean in the context of the problem? Listen to me. This is a definition, so the answer will always be the same. The period is how much time it takes to do what? To go around one cycle, all right? So we're going to say one cycle takes 7/2 what? Seconds. That's the definite. One cycle is however long that is. And you can word that a bunch of different ways. You can say it takes 7/2 seconds to do one cycle or whatever. But anyway, like that's the definition of what the period of a function is. All right, and then what is the value of A? I would draw a picture. We've got this center line, which would be where? Look at your equation. Which number from up here tells you where that center line is? It would be 5. 5 is where that center is. And then here's your wave. what is the high point and the low point? Because they told us those two. 9 is the high point and 1 is the low point. So you're being asked for the value of A. That's this distance. Well, what do you guys think? 4. Do you see how we got 4? If you take 5 and you add 4, you get 9. If you take 5 and you subtract 4, you get 1. We all good? It should make sense, right? Like common sense. That's how a lot of these are. All right. Try another one. In a city, the amount of pollution is greater during the work week when all the factories are operating and people are there and they're driving their cars and stuff. And then it goes down over the weekend when everyone goes home and things are closed. Does that make sense? Okay. The percentage of pollutants in the air is given by this awful function. Time is measured in days, and it's going to start at midnight Saturday night. So hold on to that because we're going to have to kind of like count the days. I usually just count on my fingers. Starts midnight Saturday night. What is the period of the function and what does it mean? We're going to put 2 pi over what? Pi over 3. It's whatever's, usually I say it's whatever's in front of the x. In this case, it's t for time, but pi over 3. So that would be 2 pi times what? 3 over pi. You're going to flip it over. So what happens with that? What do you end up with for your answer? Yeah, good. Pi's cancel and you get 6. All right. Can you come with me on this? Can we pretend that a week is 6 days instead of 7 days? Because I tried to make up this problem with 7 days and the fractions became so horrible. And I do not want to try to torture you. Do you understand what I'm saying? Like why 6 is a better denominator than 7? Which day do you want to get rid of? Monday. Monday. We'll get rid of Monday. Pretend there aren't any more Mondays, okay? Can you just suspend your disbelief for the purposes of this problem or pretend it's 6? Because I tried to make it 7 and it was absolutely horrible. So I did try not to do that to you. So how would you write this in your own words for the context of the problem? Good. 1 cycle takes 6 days. So we're pretending a week is 6 days. We're going to get rid of Monday, which is today. So it's not good. Today doesn't exist. It's actually Tuesday. Right, exactly. Anyway, I wasn't trying to torture you, and the problem's a lot better if it's 6. All right, what are the maximum and minimum percentages of pollution in the air? Off to the side here, let's draw a dotted line. Where is our center? Good, 30. Do you see that 30 right there that's added at the end? Center's 30, and then draw your wave. Now look, why did I make my wave go down first instead of up? Why did I go down first? Yeah, do you see that negative? That means it reflected it. So we're going to go down first. And then how can I get these numbers, the maximum and the minimum points? Because that's what I'm looking for. 12 is your amplitude, all right? So if you do 30 minus 12, what do you get for the low point? It'll be 18. And what were the units for this? It was percentage, right? Because it's like percentage of pollutants. All right, and then your maximum, you're just going to take 30 and add 12, 42%. C is asking when do those maximum and minimum percentages happen? For that, I would make a table. So we've got time and we've got pollution. If you want to write X and Y, that's fine. It doesn't really matter, but we're just going to make a table. You need 5 blanks on your table. When I set up the tables for you, like I did on the quiz review and like I did the notes last time, there's always 5 blanks. That's going to be one whole cycle. So we're going to start at 0. That's our beginning. What did we say 1 period was? We answered it already. It was 6. Good. So 0 to 6. There wasn't a phase shift. Do you see that in there? There's nothing added or subtracted. That's why I started it at 0. But usually in word problems, you start at 0 anyway. All right, what's halfway between 0 and 6? 3 will go right here. And then break it down again. Halfway between 0 and 3, 1.5 days. halfway between 3 and 6, 4.5 days. Now these you can get from your little drawing. You're gonna need to just watch me point to it. Where do we start? 30. And then it goes down to, what do we say this was? 18. And then it goes back to 30. Good. Sounds like we're getting the hang of it. And then up to 42 and then back to 30. So if you just draw a little sketch, then you've got it. All right. So when do the maximum and minimum percentages happen? Here's the maximum. Now, unfortunately, we're going to have to count. Our time started midnight on Saturday. So come with me on this. We want to go 4.5 days. From midnight on Saturday, midnight on Sunday, midnight on Monday, midnight on Tuesday, midnight on Wednesday. And if you go from midnight on Wednesday, halfway into the next day, when is it? Noon on Thursday. So the maximum is noon Thursday. I forgot to get rid of Monday. We'll just get rid of a different day. All right, and then the minimum, do you see how our minimum is here? We need to go 1.5 days from midnight on Saturday. So one day would take you to midnight on Sunday. If you go another half a day, that's noon on Monday. Cool. All right, and then the last one, at times 3 days, midnight on Tuesday night. What is the percentage? Well, we just made a table. At times 3 days, what's our percentage? 30%. Just look at your little table. Cool. Oh, I like this one, the windmill one. All right, the height of the blade of a wind turbine as it goes around and around, turns through an angle theta, is given by this equation. Height is measured in meters. Now your angle is your input, that's going to be in radians, okay? But we're talking about the edge of the turbine. Can you watch me point to this? You're going to have a little bit of an imagination. Can you imagine this spinning around? Do you see how it goes up and then goes down and comes back to the center? So it would be a wave if you graphed its height. All right, anyway. What is the period of the function? You're going to put 2 pi over... yeah, in front of the theta, which takes place of your x there, there's really just a 1, so it would just be 2 pi. So what does that mean in the context of the problem? Yeah, 2 pi should make sense because that's what? Once around the circle. So this one, we said 1 cycle takes 7.5 seconds, 1 cycle takes 6 days. So we're going to say 1 cycle, I'm not going to say takes because it's not really time. I'm just going to say is 2 pi radians. And that should make sense once around the circle. So what are the maximum and minimum heights? Let's do the same thing we did in the other one. Draw your little center line. Look at your equation. What's your center? 40, good. I'm going to draw a little wave. And what are you going to add and subtract to get your high and low points? Do you see that 8.5 there? So if you add, what's your maximum? 48.5, I think it was meters, right? And then if you subtract 8.5, yeah, 31.5 meters. So you just add and subtract. You figure out where the center is, then you add and subtract that amount. All right, and this is the part I like about this because this is going to make you think. I want to see if you guys can figure it out without me telling you the answer. Explain what the value of 40 means in the context of the problem. All right, look, 40 is when this dot is at the center. So if you think it goes up, it comes back to the center. It comes down, it comes back to the center. It goes up, it comes back to the center. What does the 40 represent in the picture? It represents the what? It's a distance in meters, 40 meters. Like what part of this could I label as being a distance of 40 meters? How tall the windmill is. This distance is 40 meters because if that's where the center is, it's going to go above that, it's going to go below that. But this is where, do you see what we're saying there? All right, so we're going to say that's the height of the turbine. And so if that's the 40 meters is the height of the turbine, what's the 8.5? Well, it goes 8.5 above that center and 8.5 below that center. So what's the 8.5? Yeah, the length of the, what do you want to call that? The blade of that. So we're going to say the length of each blade. 8.5 meters, those things are huge. You've seen them out in the countryside, right? If you go like on a long car trip. Or if you go to Virginia Beach, don't they have some out in the water? Do they have some out there? I feel like they have some out in the water. All right, last one. A child is at the wave pool, riding up and down on the waves, kind of like the signal buoy, except it's a person. All right, time is in seconds, height is in feet. How would we find the period of the function? I've done 3 of them for you. How do we do this? All right, 2 pi over, good. Pi over 4. It's whatever's in front of the x. So that would be 2 pi times 4 over pi. And so what do we get out of that? 8. Perfect. Pi's canceled. And then we're going to write a little sentence, but it's the same sentence we wrote for all the other ones. What does it mean in the context of the problem? All right, so what's our little sentence that we're going to put? Yeah, 1 cycle is 8 seconds. So it's 8 seconds for her to go up on a wave and go down and come back to like the center. All right, what are the maximum and minimum? Off to the side here, draw a little dotted line. Where's the center? Close. Yeah. Do you see at the end there's 7? So draw your little wave. What are you going to add and subtract to get your maximum and minimum? 2. So your maximum is 9 feet and your minimum is 5 feet. But she's floating in the water. And then I would make a table, leave 5 blanks in it. 2, 3, 4, 5. Now there is a phase shift in this one, so I can't start at 0. It's kind of weird. Usually word problems don't have that. What's your phase shift? So it means you went right 1. So we're going to start at 1. What was the period? We found that already. What did we find that to be? 8. So 1 plus 8, 9. And then you break it down to what's halfway in between. So halfway between 1 and 9, 5. You remember me drawing a number line though and saying you can just leapfrog to the center? If you struggle with that, just make a number line. You can count it, right? Halfway between 1 and 5 is 3, and then this one's just counting by 2s. And then watch me point to this because you really don't have to do any work. Where do you start? 7, good. And then it goes up to 9. And then back to 7. And then down 5, and then up to 7. So it says, when do these heights occur? The maximum is 9 feet at what time? Just find it on the table. 9 feet happens at 3 seconds. And 5 feet, these are the 2 we're looking at. 5 feet happens at 7 seconds. And then the last one, you're just going to read your table. What is the child's height at 5 seconds? Well, look on your table at 5 seconds, 7 feet.